Okay, Assalamualaikum and very good morning. So for today, we will continue our last lecture, which is fabrication of MMC for part 2. So before this, we have learned about solid state and also liquid. Okay, for today, uh, I will continue our topic, fabrication of metal metric composite. Deposition technique processing, which is the last part for this topic. So we have divided into two, cold spray deposition and also the other one is vapor deposition. So depositions means the process refers to the process of deposition of the metric material by adding a metal spray droplets imposed on the preform or reinforcement. So if you see the preform, it means reinforcement. Okay, the main deposition process is cold spray deposition. Other deposition technique not widely used, which is physical vapor deposition (PVD) and chemical vapor deposition (CVD), sputtering and electroplating plasma spraying. First, we will see what is cold spray deposition. So this method uses concept the formation of metal powder through atomization method. Only particles or powder reinforced material only suitable for this method. So for cold spray deposition, only particles or powder reinforced material suitable for cold spray deposition technique. So this is the diagram of spray core deposition production of SiC particulate. So as I mentioned earlier, the suitable material that can be used is particulate or powder. So this is the SiC. We use our main material is SiC, and SiC is particulate or reinforcement. So this is the furnace. We melt down our metal inside here. So this is the atomization, where this is the spray chamber. So the SiC will spray into the MMC, molten metal, and then it has pressure relief fan. We will release the pressure within this chamber. So after that, if have overspray powder into the molten metal, the SiC particulate will flow over here. Overspray powder. You come to here, and this is the collector for overspray powder, as you can see here. Here. So the process metric metal is melt inside the furnace. Molten metric metal flow into the spray chamber. The melt flow rate is controlled so that the flow velocity in the form of a uniform thin stream into the spray chamber. During the melt flow into the chamber, it will be sprayed with high velocity atomizing gas to break up the flow of melt into fine droplets. Here is the important part. So, at the same reinforcement material include with the slow and control droplet mix with the metal metric. So, this technique you must control the spray, which is that I showed you earlier. We must control the SiC particulate. So it has advantage and disadvantage for this method. First advantage, the contact time between the molten metal metric and reinforcement is short. This will reduce the ability of the occurrence of a chemical reaction between the materials. So for the disadvantage, the cost of production is very high, and the resulting composite have to go through to the process of machining and forming to obtain the product as required. So this method, after you get the sample, you must go for the next process, which is machining and forming to get desired size. Then next is vapor deposition. Vapor deposition refers to any process that involves a metric material or reinforcing the state through a process of condensing the steam, evaporate, chemical reaction or transformations to form a solid materials. So this is the main point that you must know for vapor deposition. Vapor. So it uses gas, steam, evaporate. And then it also uses chemical reaction or transformation to form a solid materials. So you have two categories. First, physical vapor deposition, which is PVD, and also chemical vapor deposition, CVD. First is PVD. Physical vapor deposition, the metal is transformed to the vapor phase by volatilization or cathode sputtering in vacuum. Okay. So the metal is transformed. This is the main. So the metal vapor is then transferred to the substrate and is allowed to condense there to form a coating. Ti reinforced SiC monofilament. This is the sample or example. So this is the schematic diagram of evaporation equipment. This is the vacuum system. This is the wafer holder, and then this is your metric. This is your inside here is your reinforcement. So as you can see here, in DC diode sputtering system, argon is ionized by a strong potential difference, and these ions are accelerated to a target. This is the target. So it will suck into this substrate. So after impact, target atoms are released and travel to the substrate where they form layers of atoms in the thin film. This is the target. So it will transfer to the substrate when this is the chemical reaction. And then the second one is CVD, chemical vapor deposition. The workpiece in an environment at reduced pressure and at relatively high temperature is exposed to a gas from which chemical reaction products deposit on the metal surface, tin, EIN, TIC, and also alumina. So this is the schematic diagram for CVD process. This is the TICL, and then if we use chemicals, this is the chemical that you use, H2 and CH4. It will transfer to the metric. So this is the simple process, and this is rarely used for the technique CVD and also PVD. So what is in situ technique in MMC? Involve a chemical reaction resulting in the formation of a very fine and thermodynamically stable reinforcing ceramic phase within a metal metric. So it reinforced with ceramic. Your MMC is reinforced with ceramic. So in situ technique processing, in situ composite reinforcement are synthesized internally. So this is the part for in situ. It's synthesized internally in the metric during the composite fabrication. So it's synthesized internally dalam metric. Dalam metric itu sendiri, dia synthesize. So this technique where the composite is produced through a phase change, which is reactive or cooling materials during the manufacturing process of composite reinforcement. So this is the reactive process or perubahan fasa, phase change, gas to liquid, liquid to liquid, solid to liquid. So for the morphology change, it has deformation process and directional solidification eutectic, which is DS eutectic. So this is the reactive ataupun perubahan fasa, gas to liquid. This one is liquid to liquid, and also this one solid to liquid. As you can see here, this is the gas inside the liquid. We combine and it will synthesized internally inside this one. So for the liquid, which is we use liquid and liquid to combine together. A plus XY in situ composite. Cu plus TiB2 mixed alloy. And then the last one is solid liquid. This is your liquid at the outer one, and then this is the solid. Example, A plus XY in situ aluminum plus TiB2. So this is the phase reactive. So for morphology, back one is reactive and the second one is morphological. First, deformation process. This is the deformation process, and this is the dF eutectic. When it reach the eutectic point, it will change and it will combine with these two. So please check what is eutectic point. Eutectic point in the morphological. So first, for deformation process, example that you simply can see, which is in extrusion die. This is the metric, your titanium Ti. This is the metric, and this is the combination of Al3 Ti plus TiB2. This is your reinforcement. This one. So it blended powder constituently can evacuate and seal here by using extrusion die. So in situ fabrication of MMC by unidirectional solidification, which is you have this is the schematic diagram for this is the molten alloy, this is unidirectional initial alloy in solid state. We will combine, we go through to the molten metal, and then this is what you get, unidirectional solidified MMC. And as you can see, here is what we call preform. And then we go through to the molten metal, and then you get the unidirectional. So that's all for today, and last class for me for composite materials. So thank you very much. If you have any question, feel free to ask me in the group. Thank you.